welcome to the second module of the ocean observing systems. In the first module we have seen about the different sensors placed in the for ocean observations in different platforms. So now in this core module we will be able to cover the what are the ocean observing platforms. So that we will cover it. So the first one is the tide gauge. The tide gauge is one of the oldest and foremost ocean observing systems measured all along the coast. The important parameter measured from this tide gauge is sea level. It is mainly in the open ocean, coastal ocean, and the parameters measured every 1 second it is acquired the data, and it is having variety of technology available for measuring this tide gauge. So the first one, simplest one, is a float tide gauge. So basically it is having floated in the water and it is attached to the string. Once the sea level increases, the string length will decrease, and increase in the length of string we will be able to monitor the sea level. And later on the pressure gauge has been used. Pressure gauge is basically the amount of water column above the sensor. So depending upon if it is a sea level increase, more pressure will be exerted at the sensor level, and accordingly it will be monitor the sea level. And the third one is radar gauge. It is basically send the microwave pulse to the ocean, and due to travel time we will be able to know the sea level changes. And the last one is a acoustic technology. It is also basically same thing like radar, but here acoustic sound pulse will be sent to the ocean, and the travel time provide the sea level informations. So these are the various tide gauge installed world over the globe, and this provides the real-time data to the GLASS website. And if one needs data, you can always refer the GLASS website, wherein you will get all the data about the tide gauge. So these are the typical applications of a tide gauge. So it is possible to resolve various components of tides like M2 or O2. All these things we will be able to do it, and also it is also used for the long term sea level changes. This is the only instrument it is available for more than 50 years record how the sea level is changes, and also it is possible to distinguish whether storm surge or tsunami arrival at that locations in the sea level. This is a typical observation wherein you can get whenever tsunami comes how the sea level changes, and this is the long term record of sea level changes in the ocean. And the next platform is a voluntary observing ships, and voluntary observing ship is basically the ships whatever is operating in the ocean as a container vessel and other things. They monitor weather informations, especially some of the vessels they mounted automatic weather station. Some of the instruments will have only limited amount of observations, and some of the ships they have visible observations. It has been classified as selected ships, supplementary ships, and auxiliary ships. The important parameter is monitor is a wind, air temperature, humidity, sea surface temperature, and sea level pressures, and also some of the cloud amount and other things also it has been monitored and sent to the source station in real time. At any point of time around 5,000 ships are reporting this type of information because it is a voluntary observing systems, and this is a typical observation where SST is available. So wherever the red points are there where you have more number of observations, and some of the blue is less number of observations. Now whenever the technology is improving, now the ships of observations also it is slowly decreasing. So this is a number of SST observation how it is increased over the recent years it is mentioned. And what is the application of voluntary observations? Earlier we don't have any technology to measure air temperature or humidity and wind speed in the oceans, but now we have a lot of technology. But for the past records we rely on the voluntary observation ships records, mainly for large scale estimate of ocean observation, ocean atmosphere exchange of heat, fresh water, and momentum. For the decadal level of observation we only solely depend on voluntary observing ships. The other platform is ships of opportunity, This is same thing, it is also voluntary observing ships, but here we are trying to monitor the ocean. So this is the first time in along the ship route the temperature up to 700 meter it has been monitored by XPT instrument. That is unlike voluntary ships, here some technician has to sit on board ships and he has to continuously operate XPT. The XPT is basically three modes of deployment is possible. One is low density, and second one is frequently repeated, and third one is a high density. It is basically the number of deployments along the cruise ship route. Suppose in Mumbai to Mauritius, every day if you deploy about 4 XPT, it will be low density. If you deploy 6 XPT, it will be frequently repeated XPT, and high density is basically 35 XPT if you operate. That means 35 location you will have a temperature up to 760 meter depth. This is a typical instrument how it operates. Basically there is a thermistor probe. In the probe is attached to the ship in one of the corner, and once you fire that probe, it will go to the bottom of the, it will go to the sea, and whenever it goes, and it will continuously provide the temperature data to the main motherboard of the ships. And but it will give only temperature, but it will not give the depth. But the depth indirectly we calculate using the fall rate equations. That means before itself, for this density, this much weight of the instrument, if it falls, what depth it will be reached at what time. So from that we will find out the depth of the measurements. So we know the depth from the fall rate equation, and from thermistor we know the temperature. From that we can construct the temperature up to 760 meter. But however, the accuracy is about 1.15 degree Celsius. And these are the typical XPT routes wherever the ships operates. These locations we will have a more than decade old temperature records up to 750 or 800 meter depth. So these are some of the proposed location where the XPT network is mandatory or requirement in order to understand the climate. So these are typical application of XPT. So basically we in this XPT first time we are able to monitor seasonal changes of heat in different oceans. So we will have also geostrophic velocity and large scale ocean circulation up to 800 meter we are able to monitor. So mainly this provides the what is called the heat content up to 800 meter. Especially it is very useful for the boundary currents region where the large amount of heat is transported from one place to another place. The other platform is a drifting buoys. So the drifting buoys is basically the meteorologist and the oceanographer combined together. They started this drifting buoys where the air pressure is a very important parameter for the meteorologist, whereas the SST is very important for the oceanographers. They put to join together, they are able to devise a platform. It is a drifting buoy, and it is also provide the mixed layer current informations. The important problem is it is having biofouling, and it communicates real time using Argos and Iridium communications, and once in hourly or 3 hourly it transmits to the shore stations. This is monitored by the Global Ocean Observing System, and it is the mandatory requirement in the entire global ocean is about 1250 drifter. It is in order to resolve entire global oceans, and it is roughly about 5 degree by 5 degree box. It is roughly about 500 kilometer by 500 kilometer. One drifter is necessary to resolve the ocean. And this is the typical instrument. This instrument is basically a float. It will be float. There is some float is floating on the surface, and it is attached to the big drogue, about a 15 meter drogue. It is like a net. So water will go around this one. And now in this it is attached to the temperature sensor and the barometer, that is a pressure sensor. It is attached to that, and it will be thrown into the ocean, and wherever the current it is carrying, and this float will be going according to the currents, and from that we know the position of the float, we know the what is the mixed layer currents, and also it communicates the temperature and the air pressure measured by this. It will transmit to the satellites. From this we will get the mixed layer currents, temperature, that is SST, and also air pressure we will continuously monitor from the ocean. So these are the typical locations where the drifters are placed right now, and it is continuously providing the data to the users, and the various countries are contributing to monitor these drifters. So these are some of the typical applications. So from the drifters we get the mixed layer currents, and it is used for climate research and monitoring, and also it is validate model results and to resolve kinetic energy, and also for search and rescue operation it is widely used. The other important platform is a moorings. Basically here it is a automatic weather station in the ocean. So you anchor it, this entire buoy, it is about 3 to 4 meter diameter. This buoy is anchored, and there in the top of this is a float, it will be floating, and the top you have a met sensors, and the bottom up to 500 meter various instrumentation of temperature and salinity and pressure sensor is attached up to 500 meter. So essentially this buoy provides meteorological and ocean variables at a fixed location for every second, every minute or seconds or every hourly, and it is also transmitted in real time. So we get the weather information in the mid of the oceans. So these are the various kinds of buoy type. Omni is mainly used by India, and Atlas, Triton, Sea-Watch and other type of other countries are using this name of the mooring. So earlier this TOA and Triton array was TOA and Pirata was dominant in Pacific and Atlantic, but in Indian Ocean it was a data void region. No mooring was there. But from 2008 we have started this new mooring in the Indian Ocean, that is a Rama. So now the Rama is in about 48 mooring is in place. Apart from Rama, India also deployed many moored buoys in the Bay of Bengal and the Arabian Sea. It continuously provide the data in real time. So this mooring application is it is one of the important platform to resolve the diurnal to ISO time scale. You get the various parameters of meteorological and oceanographic variables, and also it is very useful for cyclone. Suppose if any cyclone formed in the Bay of Bengal, we will get the pressure drop and wind speed much in advance, so that we will be able to prepare well in advance. And also it is also find out the mixed layer dynamics, how the mixed layer budget is at that location, and also it is very used for validation of model results and the satellite data. So this is a typical temperature record and salinity record and wind and current record. All these things one of the buoy provides like this informations. So the next important platform is Argo profiling floats. This is a new way to take measurements from the ocean. Basically it is a oceanographic radio sonde. Atmosphere, they used to launch a balloon to up to the troposphere. Similar things in the ocean, they launch this Argo floats up to 2 kilometer depth. So this is basically to the importance is basically to resolve and improve ocean and climate forecasting and understanding the mass and heat transport, and from that finally the end result is to predict the seasonal to climate variability of information. So this is a typical float, how it works. Once this float is deployed into the ocean, it dives up to 1000 meter depth, and afterwards after 1000 meter it drifts for 9 days. After 9 days then it goes dive up to 2 kilometer, and after that 2 kilometer when it is reaches, then it comes to the surface. When it comes to the surface, it continuously monitor and acquire temperature, salinity and depth information, and once it reaches the surface it sends to the data to the satellite. From the satellite we receive the data into the shore informations. So how it works? Basically this float is having a what is called, this is the main mechanism. Basically the mass is a constant, and by changing the volume, the density of the entire float is modified. Using that it goes up and down, so that we can precisely send the float up to 2 kilometer and it comes to the surface. The accuracy of the sensors is very high, and it communicates through Argos and Iridium. Initially it started with the temperature and salinity. Now there are many other sensors for oxygen, chlorophyll, rain and nitrate and light attenuation sensors also added in the float. And these are the typical applications one can see from the Argo, like temperature, barrier layer and geostrophic velocity, and there are many applications we can use from the Argo informations. And using this Argo information, now CTD is available. Instead of Argo, the CTD sensors also attached to the seal, especially for Antarctic and ocean region, and this seal it will dive up to 500 meter, and you will get the up to 500 meter temperature and salinity information wherever it goes. So this is called animal Argo. But of course there should not be any confusion between bio Argo and animal Argo. Bio Argo is apart from temperature salinity sensor, there are biological sensors also attached, that is bio Argo, but this animals also provide the temperature and salinity records. So up to now we have seen various platforms of tide gauge, voluntary observing system and ships of opportunity, drifting buoys, moved buoys and Argo floats. Now in the next module we will be looking at the further platforms like gliders and other things. We will look into that, and the fourth chapter we will be looking at satellite and other informations.